Hello and welcome to today's video. Today's video is for Advanced Geometry Chapter 10, Section 7, Areas of Circles and Sectors. So the first thing we start out with is the area formula of a circle. So the area of a circle is pi times the radius squared. And then we have a definition for something that's called a sector. A sector is a region bounded by an arc and two radii to the arc's endpoint. So if you look at this, kind of think of them as pieces of pie. These are called sectors. Okay. Now, in order to find the area of a sector, it's kind of like when we did the arcs yesterday. What we do is we take the arc measure divided by 360, or basically what part of the circle do we have, and then we just multiply it by what would be the area of the entire circle. So if you take the measure of the arc divided by 360, that gives you the part, and then you multiply it by pi r squared, and that gets you what the sector is. So for example, what we have here is we have the area of sector ZOM. So notice they use 3 letters. It's kind of like an angle. We just have to put the word sector with it. So the middle letter should be the center of the circle. So what we have to do is we have to say, okay, well, we've got 72 degrees out of 360 degrees for the entire circle. And if we had the entire circle, it would be pi times 20 squared. So 72 divided by 360, that can be simplified into 1/5. And 20 squared is 400. And if we take 1/5 of 400, we get 80 pi. And since we are in centimeters, this would be centimeters squared. Now, we can have a segment, which is a line. We can also have a segment of a circle. Now, a segment of a circle is a part of a circle bounded by an arc and a segment joining its endpoints. So if I take a look at the picture I have here, the segment would be this part right here. And the way that I can find the area of the segment is I can take a look at the part that makes up that part. So the area of any segment is going to be the area of the sector minus the area of the triangle that would connect the endpoints and the center of the circle, so the area of the triangle. Okay, so if we take the sector and we subtract off the triangle, we get the area of the segment. Okay. So we have an example here, and I'm not going to round to the nearest tenth. I'm going to leave it in exact form. So find the area of the segment. So the area of the segment is equal to the area of the sector minus the area of the triangle. So the area of the sector, it is 1/4 of the entire circle, and the whole circle would be pi times 10 squared. So this is 1/4 of 100, or 25 pi. Now, when you do the triangle, make sure you look and you use the easiest formula you can. You can use 1/2 BC or the sine of the angle. You can also use 1/2 base times height. So make sure you take a look at what you have and you use the easiest formula you have. The easiest one for this, since it's perpendicular, is 1/2 base times height. So 1/2, 10 times 10. So this is going to be 1/2 of 100, or 50. Okay. So the area of the sector is going to be 25 pi minus the area of the triangle, which is 50. And that's the best we can do in terms of simplifying it. So what I'm going to do is I'm going to put in parentheses, and then I'm just going to put the units after it. So this is inches squared. Next thing we have is the definition of a loon. This is not in your book, so this is something we're adding, and we will do some loons. It is a concave convex area bounded by 2 circular arcs. So what I have next is some examples of loons. So we have two circles, and where they intersect, or where they overlap, or where they don't intersect, is called a loon. So you notice we have various shadings in here. There's multiple loons within these pictures, and they're just showing you one of them. So it can be the outer part. It could also be what I sometimes consider the inner part. So I'm going to do an example in class. If you want to think about how you would solve this problem, just draw it somewhere in your packet and we'll talk about it. What I have here is I have a 6, 8, 10 triangle. It is a right triangle. And then I did 3 circles. Each of the circles is centered at a midpoint of the triangle. So if you take a midpoint of the hypotenuse, that's the center of a circle. If you take the midpoint of both of the sides, that's the center of the circle. And what that creates is 2 loons, and I want to find out the area of these loons. And it turns out the area of these loons is really cool, so we'll figure them out in class, but take a look at it and see if you can figure it out. And that is it for today's notes. Thank you for watching. Have a great day.